Alright, so now we will discuss auto transformer. So here, as in case of two winding transformer, we have two individual winding, right? Then we can denote like this also, core. Okay. Here we have only one windings like this, as shown in diagram also. Alright, here it is V1, here it was V2, here we have this one as V1 and this one as V2. Only one winding. Like here, this one is only one winding we have. We will give the primary side this voltage V1 on this side, then you can get the voltage on the secondary side. Here, these are the different tapping points we have. Alright, to increase or decrease the magnitude of the voltage on the secondary side. Okay. For example, here, if you have apply here V1 200 volt and this is your slider, this one. So if this arrow is here, then in the output you will get same value 200 because voltage in parallel will remain same. So if this is 200 up to this point, so it will be 200 in secondary. Now you can calculate the voltage per turn. For example, if we have here 50 turns, N1 is equal to 50. So voltage per turn, voltage, or we can write here voltage per turn will be 200 divided by 50. So it comes out to be 4 volt. Now in secondary, what will happen? You will get 4 volt per turn, primary as well as secondary. Now if you change the number of turns, for example up to this point, here if you select like this, so number of turns will be less. For example, if we count, this is 1, 2, 3, 4, 5, 6, 7, only 7 number of turns. So you will get in the output 7 into 4, 28 volt. Alright. So in this way, if you move this slider here, then number of turns will increase, so the voltage will increase. Similarly here, okay. So in this way, the auto transformer is giving you the output voltage. Okay. So here we have tapping. Then here you can move this slider here, here, here like this. But we have some arrangement that we can move your slider at this point also, at this point also, at this point also. We call this one as the continuous variation. And for this we have this one. And we call it the variac also. Here you will see this is your, here it is primary voltage. So this slider you can move this one up or down continuously. Alright. This one we call this one tappings, and you have used auto transformer in your lab also, and you have used this one, the continuous variable, means you can get in this, in case of tapping, maybe you will get like this 50, 100, 150, 200, like this. But in continuous variable, like this one, you can get the voltage like 100, 101, 102, 103, like this, when you move this one here or the upside. 0, 1, 0, 2, 101, 102, 103, and so on up to 200. Alright, so this is the advantage for this continuous type of auto transformer. But these are not the isolate one, because it is on single winding we are using. Two winding transformer are the isolated transformer. Now, this is the auto transformer you have used in your lab. Alright, so this is your positive and negative phase or neutral, you can say. Alright, in lab we will show you also, but here we have this structure, this one, or the, when we open this, so these are the windings, copper windings. This is the brush which we can move this one, here we have this numbering 10 volt, 20 volt, 30 volt, 40 volt, 50 volt, 60 volt. Alright, we call this one as slider. Right, this one also, this portion slider, which can slide and rotation motion, and like this also. Yeah, now you are moving this one, we have discussed this one like this, or the upside. So this arrow point indicates this brush. Now you are moving this brush up and down. So here you will rotate this one, and clockwise or anti-clockwise. When you are rotating this one, for example clockwise, then you can say it will goes here, upside or downside, any one direction. And if you move this anti-clockwise, then it will move in the opposite direction. And if you remember, initially this slider will be here like this, because when you turn on your auto transformer and marker is on 0, it means it is here, so voltage is 0, output of the auto transformer is also 0. When you move this one upside, for example here, means you are moving in clockwise direction. You move your transformer in clockwise direction, then this slider will move upside and your voltage will starts increasing. Okay, like 0, 10, 11, 12, 13, 14, and up to where you make your slider at rest. So you can change now like this the output voltage of the auto transformer. Right. Now we can make the arrangement like this also. You can use step down auto transformer also, step up auto transformer also. And in single transformer, in one auto transformer, you can do both this operation also, step up and step down. So first is for step down auto transformer, you will see you have apply AC source here. Number of turns on primary side is high and number of turns on secondary side is low. It means it will be step down transformer. Current I2, voltage E2. Alright. And if you change the position of source and load, now you see source is here, load is here, naming is also changed, E1, I1. Alright, then you will see number of turns on primary side, primary is this one, AC source is less, only this much, and number of turns on secondary side is high, so it will become a step up transformer. You will get high voltage on the secondary side. Alright, so this is the theory portion. It is a transformer with one winding only. Part of this being common to both primary and secondary. So common part like this is common. This portion is common to both primary and secondary. Alright. Primary and secondary are not electrically isolated from each other. Okay. And the equation will remain same as in case of two winding transformer, that V2 by V1 is equal to N2 by N1 is equal to I1 by I2 equal to K. Alright. So you will see this diagram, we will study this, that current I1, this is for A, this is the step down transformer. So when you apply voltage V1, current I1 will starts to flow, and then a load is there. Then in the secondary we have I2 current flowing is this side. So in this portion, which is common, this one, current will be IC, and that is equal to I2 minus, here it must be minus I2 minus I1, here I1 minus I2. Alright, so when if you have any doubt, then you can apply the KCL at this node. So we are saying I2 minus I1 is coming this side. Alright, I1 is coming this side. So entering current at a node must be equal to leaving current at a node. So when you add this I2 minus I1 plus I1, it will be I2. This side. Alright. So I2 is here. Right. Here also you can apply KCL. Outgoing current must be equal to incoming current. So outgoing current is I1 and here it is I2 minus I1. So I2 minus I1 plus I1 will be equal to I2. Similarly on this side also you can apply. This is your step up transformer. This side. So here the current in section CB. So we can drop this one. So section CB, this section CB, a difference of I2 and I1. But as the two currents are practically in phase opposition, the resultant current is I2 minus I1, where I2 will be greater than I1 because power should be remain constant. So if voltage here is less, so current must be high. Alright. So as compared to an ordinary two winding transformer of same output, an auto transformer has higher efficiency. So because leakage will be very less, so the efficiency will increase because we are using only one winding. Now the important thing, that the saving of copper, how much copper means the windings. When you are using two winding transformer, you have to use different winding on different limbs, primary winding as well as secondary winding, so the volume will be high of the winding, the copper. So in auto transformer you will save some amount, and we have to calculate that how much you will save so that it will be more economical. So now we know weight of copper is proportional to the length and area of cross section of the conductors, means this winding. So how much is the length and what is the cross section area. Alright, so weight of copper will depend on this, then it will be the volume. So now length of conductor is proportional to the number of turns. If number of turns is high, then the length of conductor will be high, large. And cross section depends on the current. How if you want to flow more current, then cross section must be high. So hence from here we can say weight is proportional to the number of turns and current and number of turns. So from here we will derive this one. Weight of copper in section AC, right? So you have this section AC, this one. So number of turns here we are assuming N1, here we are assuming N2. Alright. So number of turns in section AC will be N1 minus N2. This much. That's why we have written N1 minus N2. And current flowing is I1 up to this point. Then it will be divided I2 this side and I2 minus I1 this side, upside. So we have multiplied I1. Weight of copper in section BC. BC, sorry, this one. Current is I2 minus I1 and number of turns is N2. So it is N2 into I2 minus I1. So total weight of copper in auto transformer, we can add this to AC plus BC. So it will be N1 minus N2 I1 plus N2 into I2 minus I1. So you can add these two. So you will get total weight of copper in auto transformer. And if you are using two winding transformer instead of an auto transformer, then you have to use a separate primary winding and secondary winding. So weight of copper at that time it is N1 I1 and weight of copper on secondary will be N2 I2. So total weight will be sum of both these. Now we will compare these two. So when you are comparing, we will get weight of copper in auto transformer is this one and weight of copper in ordinary transformer will be this one. Right? When you solve this one and take the common N1 I1 plus N2 I2, you will get this equation. And as you know, N2 by N1 is K. This is N2 by N1 K and I2 by I1 is 1 by K. So you will get 1 minus 2K by 2. So this is 1 minus K. So you can write weight of copper in auto transformer is equal to 1 minus K into weight of copper in ordinary transformer. Alright. So saving will be how much you will save, where K is transformation ratio. So saving will be W naught minus WA. W naught minus ordinary transformer, WA minus your auto transformer. So it comes out to be WO minus 1 minus KWO, KWO. Okay. Saving will be K into weight of copper in ordinary transformer. Alright. Hence saving will increase as K approaches unity. Alright. N2 by N1. So it will be increased. Now the power transform inductively. Alright. So in case of here, in case of sorry, in case of two winding transformer, power is transformed from primary to secondary by induction, mutual induction. Alright, not by conduction. Right, conduction like in the wire. Alright, this is induction. Now in an auto transformer, power is transferred by both means, conductively as well as inductively. So conductively power transform is through this number of turns only, and from this one section, this BC, power is transferred inductively. Right. So we have two different way of transferring the power. Some power is transferred through induction and some power is transferred through conduction. That's we have mentioned here. So that power transferred inductively is input into 1 minus K and that the rest of the power is conducted directly from the source to the load. It is transferred conductively to the load. Now you have to check this and derive this. This is the assignment for you, right? That how you will transfer the power inductively and conductively. Alright. So like this, we have one numerical, then it will be more easy to understand how transformer is working. Okay. So we have the primary and secondary voltages of an auto transformer of 500 volt and 400 volt. So we have mentioned here 500 volt primary voltage, 400 volt secondary voltage. Show with the aid of diagram the distribution in the winding when the secondary current is 100 ampere. So this is 100 ampere. It is given this is 100 ampere. And calculate the economy of copper in this particular case. Economy means how much you have saved the amount of copper in auto transformer. The circuit is shown. This is another circuit. So K transformation ratio can be find out V2 by V1, that is equal to 0.8. So if you have transformation ratio, then you can calculate the current in primary I1, that is K into I2, means 80 ampere. So here it is 80 ampere, and when you check power at the primary side, it is 80 into 500, so it comes out to be 4000, and secondary it is 100 into 400. So same power is same at primary as well as secondary. The current distribution, how it will be: 100 this side, 80 this side, 100 this side, then it must be 20 from this side, then it will be 100 ampere. So this is the current distribution, and from entering point this is 80 ampere here, so here it must be 80 ampere. Right. So here current is I2 minus I1, 20 ampere. Now saving you have derived in the previous also, kW naught, k times of weight of ordinary transformer. So it is k into W naught, 0.8 into W naught. So percentage saving, if you calculate, it comes out to be 80%. Depends on the number of turns. So 80% of the copper you have saved if you are using auto transformer instead of two winding transformer. Alright. So this is your auto transformer. So this is the MCQ. You can solve this. The induced EMF will be reduced to half if the conductor moves at an angle of